Today we're going to learn about the physics behind a swim cap. In other words, why do modern swimmers wear swim caps? Really, to answer this question, we need to look at the history of a swim cap. They first became popular in the early 1900s when rubber was invented and women started to wear them as both a fashion statement, but also to keep their hair dry when they were swimming. The swim caps at this time looked more like a helmet and had a strap under their neck. And the popularity of this kind of swim cap lasted until about the 50s, with women also having floral patterns and different fashionable elements added to them. The swim cap definitely dropped in popularity during the 60s, and the type of swim caps that we know today that look a lot more like this became more popular during the 70s and 80s as public pools required people with longer hair to wear swim caps, and also competitive swimmers started to popularize and wear swim caps a lot more in competition. Swimmers have to account for passive drag and active drag when swimming to maximize their speed and efficiency in the water. Passive drag is the resistance generated by the non-propulsive parts of the swimmer's body. This would include anywhere that is not the arms below the shoulder. This would be the head, the sides of the head, the skin on your chest, your legs, like everything that is not actively pushing you forward in the water would be considered the passive drag acting on your body. I'm going to show two videos that are demonstrating purely passive drag with my arms at my sides swimming. Active drag is the resistance created by movements and is added to passive drag. Active drag is created when a swimmer moves their body to create propulsive forces and then spends energy in a way that moves the water and reduces the propulsive forces and pushes back against them. There are three components that make up both active and passive drag collectively. Passive drag is majority made up of both frictional resistance and form resistance. Active drag is majority made up of wave resistance. Those three together are frictional resistance, form resistance, and wave resistance. Each of those have a relationship with resistance and the swimmer's velocity in an interesting way. Frictional resistance has a linear relationship with resistance and the swimmer's velocity. Form resistance has a quadratic relationship with the resistance and the swimmer's velocity. And wave resistance has a cubic relationship between the resistance and the velocity of the swimmer. The effects of slowing are different for each form of drag. If a swimmer doubled the speed of swimming, frictional drag would be twice as much as the original speed. Form drag would be 4 times as much, and wave drag would be 8 times as much. It can be seen that these features of swimming efficiency become increasingly more important as the swimmer attempts to increase speed. To expand upon passive drag, it can be broken down into both frictional drag and form drag. Form drag can be explained as the differing pressures caused by the placement or form of a swimmer's body in the water. Form drag is reduced by streamlining your body, as seen in the top swimmer of this diagram. Here's a video of me demonstrating swimming with optimal form drag, as the swimmer here is showing. Form drag is increased when a swimmer increases the water pressure against their body by falling out of streamline, as seen in the swimmer on the bottom of this diagram. Here's a video of me demonstrating the same motion that this swimmer is demonstrating. Form drag is extremely important for a swimmer to take into account, but it is only one part of passive drag. Frictional drag is developed when the swimmer passes over a rough surface. Skin roughness, body contouring, hair, and swimsuit fabrics are examples of the roughness that create frictional drag as the swimmer moves through the water. The biggest reason that competitive swimmers wear swim caps is to reduce their swimming times. This idea would imply that swim caps have an effect upon drag, possibly reducing it. The initial question that we were trying to answer in this video is, why do modern swimmers wear swim caps? And when you think about that, with using what we've learned about the different types of drag, both passive and active, and the components that make them up, we can develop this question into, does a swim cap reduce frictional drag? To really answer the question of, does a swim cap reduce frictional drag, I'm going to reference a study done on a female Olympic swimmer. In this study, she was analyzed while holding a streamlined position that looks somewhat like this. They then analyzed the passive drag of the swimmer's model with both a cap on and off in a computational fluid dynamics simulation of her moving forward while in streamline. When analyzing their data, they found that at the same velocities, both the drag force and the drag coefficient that acted upon the swimmer was lower when wearing a swim cap. This research also shows that there was a 15% decrease in the passive drag that acted on the swimmer when they were wearing the swim cap. This study very obviously shows that a swim cap does reduce frictional drag for a swimmer in their swimming times.